Hello and welcome to Lesson 6-4. Today we're going to look at the standard form of a linear equation. So to begin with, we're going to look at what this actually means. The standard form of a linear equation is in the form ax plus by equals c. Now the a, b, and c are going to be real numbers, and the a and b cannot be zero, or they're non-zero numbers. Okay, so just to give you an example of what this might look like, we could have something like 3x plus 5y equals 7. Maybe you have 2x minus 6y equals 0. Okay, again, just notice that my a and b are non-zero numbers in both cases. And my c value, my c could be 0, they can be positive, they can be negative, but these are all real numbers. And what we would do is the letter in, or the number in front of the x, these are my a values, the numbers in front of y are my b's, and then our constants are the c's. Now, when you're given an equation in standard form and you are told to graph, the best way to graph an equation in standard form is to use our x and y intercepts. So if you think about it, if I have a graph, okay, my x-axis is here, and my y-axis is the vertical axis. So if I have a line that goes through these like this, okay, I have an x-intercept and I have a y-intercept. The intercepts are the points where the graph crosses the x-axis or the y-axis. So for my x-intercept here, I know that my coordinate point is going to be some value x, and my y value here is going to be when y is equal to 0. That is the case for every x-intercept. Likewise, with the y-intercept, I know that x always equals 0, and then my y value is just going to be whatever the number is on that y scale. So when we are given an equation in standard form, if we have to graph it, what we're going to do is we're going to use our x and y intercepts, or find them, and plot those x and y intercepts, and then we can connect the 2 points and graph our equation. Okay, so to do that, to find our x-intercept, what we're going to do, so at every x-intercept, we know that y is equal to 0, so we're going to plug a 0 in for y, and then we're just going to solve for x. Likewise, for our y-intercept, we have to set x equal to 0, and we're going to solve for y. And we'll look at a few examples and see how this is going to work. So for example 1, it tells me to find the x and y intercepts of 3x plus 4y equals 8. So again, to find my x-intercept, if we think about this graphically, okay, so my x-intercept is going to be this point right here, and I know that on this x-axis that I have an x value, but every y value is 0. So what that means is when I go to solve for my x-intercept, I'm going to plug a 0 in for every y. So I have 3x plus 4 times 0 equals 8. So now what I'm going to do is I'm going to go ahead and solve. Well, 4 times 0, this is going to give me 0. So I have 3x equals 8, and I can go ahead and divide both sides by 3, and I see that x equals 8/3. So the coordinate point for my x-intercept is going to be 8/3, 0, because y is always 0 on an x-intercept. Now for my y-intercept, what I'm going to do is I know that my y-intercept is on the y-axis, and this is really where x is equal to 0, and I have my y value. So here I'm going to plug in a 0 for x, so I have 3 times 0 plus 4y equals 8. Well, when I go 3 times 0, this is going to turn into 0, so I'm left with 0 plus 4y equals 8. I'll divide both sides by 4, and I see that y equals 2. So my coordinate point then here is going to be my x value, which we said was 0, and my y value, which is 2. So now if I were to just do a quick rough sketch of this, okay, what this is going to look like is I'm going to plot my x-intercept, which is 8/3, 0. 8/3 is going to be it's 2 1/3, or sorry, 2 2/3. So 2 2/3 is going to fall in between 2 and 3. So I'm going to plot that like right here. Then I'm going to plot my y-intercept, which is 0, 2. So I have 0, 2. And now that I have 2 points, I'm just going to connect them. And I have my graph now. Now, if you really wanted to double check your work, you could always take this equation and put it in y equals mx plus b. So to do that, you would have to get y by itself, which means you're going to subtract 3x from both sides. So that's going to give me 4y equals a negative 3x plus 8. Then what I would do is I would go ahead and divide everything by 4. So then I'm left with y equals a negative 3/4 x plus 2. And if this is my equation, notice my b value is my y-intercept, and that's what I have right here. My slope is a negative 3/4. Well, a negative slope tells me that I'm decreasing, which I am in fact doing that here. So that means I'm on the right track. Now example 2 is very similar. It says find the x and y intercepts of 4x minus 9y. So here, to find my x-intercept, remember the y equals 0. So I have 4x minus 9 times 0 equals a negative 12. This becomes 0, so I'm left with 4x equals a negative 12. Divide both sides by 4, and I see that x then is equal to a negative 3. So my coordinate point would be x is negative 3, y is 0. Likewise, for my y-intercept, I know that my x values are 0. So I have 4 times 0 minus 9y equals a negative 12. 4 times 0 is 0, so I'm left with negative 9y equals negative 12. I divide both sides by a negative 9, and I see that y is equal to a negative divided by a negative will give me a positive. So I have 12/9, which is actually going to reduce down to 4/3. So my coordinate point here then is going to be 0x and 4/3 for my y. And then I could just plot these 2 points and graph. So for example 3, it says the sophomore class holds a car wash to raise money. A local merchant donates all of the supplies. A wash costs $5 per car and $6.50 per van or truck. Define a variable for the number of cars. Okay, so I'm going to call my number of cars x, and define a variable for the number of vans or trucks. I'm going to call this y. Part B then says write an equation in standard form to relate the number of cars and vans or trucks that the students must wash to raise $800. So if I have $5 per car, that's going to be 5x, because it's my cost times the number of cars. Then I'm going to add that to my $6.50, which is what I'm going to charge for a van or truck, and that's my y. And I know that I want this to equal $800. So this right here is my equation written in standard form. Now to graph this, I need to find my x and y intercepts. So for my x-intercept, I know that my y value is 0. So I'm left with 5x plus 6.5 times 0 equals 800, or 5x equals 800. So I'm going to divide 800 by 5, and x then is going to give me 160. So what this tells me right now is if I have only cars and no trucks or vans, I have to wash 160 cars just to make my $800. Now on the opposite side of that, we're going to look and see how many trucks or vans we have to have. So to do that, I'm going to find my y-intercept. So remember, for our y-intercept, we set x equal to 0. So I have 5 times 0 plus 6.5y equals 800. I'm left with 6.5y equals 800. When I divide both sides by 6.5, I'm left with y equals. Now this is going to give me 123.07, so I'm just going to write 123. So my y-intercept then is going to be the coordinate point 0, 123. So now what I'm going to do is I'm going to set up my x and my y-axis, and I'm going to plot my x and y intercepts. Okay, so what I'm going to do is I sit here for my x-axis. I see that I have a value of 160. So I have 12 boxes that run along my x-axis. So I think if I make each one worth 20, I should be okay. So I have 20, this is going to give me 40, 60, 80, 100, 120, 140, 160, 180, and 200. So with that then, I'm going to go ahead and I'm going to plot my x-intercept, which remember is 160, 0. So I'm going to go ahead and put a dot or a point right there. And then I'm going to do the same thing for my y-axis. And I still have 12 boxes that run vertically, so I'll probably just go ahead and do the same thing. So here I have 20, 40, 60, 80, 100, 120, 40, 160, 180, and 200. And again, the plot that I have to point is 123, so that's going to put me like just above the 120 mark. So now that I have my 2 points, I'm going to go and I'm going to connect them with a straight line. And this now is my graph. So what this graph means then is any combination that I encounter along this line is going to tell me how many cars and how many trucks I have to wash. So right here, let's just kind of pick a sample point. Okay, now my graph, okay, because I'm on the iPad, is not quite as perfect, okay, but we'll say that this right here is a point of intersection. So if I pick this point on my graph, that tells me I need to have 40 cars, because that's my x value. So if I come down here to x, I have 40 cars, and right here, this is 100. I'm going to put T/V for trucks/vans. So that could be one combination of vehicles that I get in to make my $800. All right, so let's go ahead and look at example 4. Example 4 says Larry runs at an average of 8 miles per hour. He walks at an average rate of 3 miles per hour. The first thing we're going to do is we are going to define our variables. Okay, so for walking, I'm going to call this my x, and our running is going to be y. When we write our equation, it looks like Larry is walking 8 miles per hour. Well, walking was x, so I have 8x plus, it looks like he's running at 3 miles per hour, or 3y. And when we write our equation, it says it wants to know the time that he could spend running and walking if he travels a distance of 15 miles. So again, this is very similar to the last problem. I'm going to start out finding my x-intercepts. So I have 8x plus 3. My 0 is going to be plugged in for y equals 15, or I have 8x equals 15, which means x equals 15/8. Okay, and I'm going to put that this is approximately equal to 1.875, just so we have that when we go to graph. So our x-intercept is going to be at 15/8 and 0. And then I'm going to go and do the same thing for my y-intercept. So my y-intercept, remember, my x is equal to 0, so I have 8 times 0 plus 3y equals 15. So this gives me 3y equals 15, or y equals 5. So my y-intercept, I have 0 for x, 5 for y. And what I need to do now is I need to identify the axes. Okay, so again, I have those 12 tick marks along my x-axis. My x-axis has to be a number between 1 and 2, so I might make each tick mark like a half. Or actually, let's go ahead and make it a quarter. So if I go 1, 2, 3, 4, so this is the number 1, 1 1/4, 2 or 1 1/2, 1 3/4. This is 2. And this here would be 3. So then when I look at my y-axis, I have to go up to at least 5. So I should be able to make each one of these tick marks 5. So if I go 1, 2, 3, 4, 5, this here is 5. Then what I'm going to do is I'm going to go ahead and I'm going to plot my x-intercept. Remember, my x-intercept is 1.875. So that's going to be a little bit beyond 1.75 or right here. My y-intercept is at 0.5. So I can go ahead and graph that. And I'm going to just connect those. So again, any point that falls along this line is going to be a solution. So an easy point to look at would be 1 right here. So what this tells me, in order to travel the 15 miles, if I go down to my x coordinate, this is 3/4 of a mile at a walk. And if I go over to my y axis here, it looks like that's at the point 3, which is going to be 3 miles at a run that he could do, and he could complete his 15 miles using the rates of 8 miles per hour at a walk and 3 miles per hour at a run. So our final example says, suppose you are preparing a snack mix. You want the total protein from peanuts and granola to eat 28 grams. Peanuts have 7 grams per ounce and granola has 3. So write an equation. I'm going to say that my peanuts are my x and my granola is my y. So this tells me that I have 7x plus 3y equals, and I want to have a total of 28 grams. And I got that from right here. Now I'm going to go ahead and graph my equation. So again, I have my x-intercept, which is 7x plus 3 times 0 equals 28. 7x equals 28, or x equals 4. So my x-intercept is going to be at 4, 0. Likewise, I'm going to find that y-intercept. So that means x is 0, so I have 7 times 0 plus 3y equals 28, which gives me 3y equals 28, or y equals 28 thirds. And 28 thirds is really approximately equal to 9.3, so when we go to graph. So our y-intercept is 0 and 28 thirds. Now, for my x axis, because I have an x-intercept at 4, I can go ahead, I'm just going to make each tick mark a half. So this here is 1, 2, 2.5, 3, 3.5, 4, 4.5, 5. And then on my y-axis, because I have to go to 9.3, I'm just going to go up to 10. So I'm going to make each tick mark 1. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I'm going to go ahead and I'm going to plot. So I'm going to plot the point 4, 0, which falls right here on my x-axis. And remember, that's 0, 9.3, so that's going to be just past the number 9. And then what I'm going to do is I'm going to connect my points like this. And it says, use the graph to find how many ounces of granola you should use if you use 1 ounce of peanuts. Well, peanuts are my x value, okay, and we identified that up here. This is why I always like to write down what my x and y are. So here, if I start out at x and I go up to my graph, then I'm going to go over to my y, and I can see that I'm here at 7. So what that tells me is if I have 1 ounce of peanuts, I must have 7 ounces of granola in order to get my 28 grams of protein. Please let me know if you have any questions. Otherwise, have a great day.